the cotangent of x. It has a lot of similarities with the tangent of x. This next slide, I want you to write everything down. I do want you to notice one big difference with your asymptotes for your cotangent. The left and right asymptotes right here. With the tangent function, if you remember, the asymptotes were at negative pi over 2 and pi over 2. Different. This is 0 and pi. And then everything else is still the same for the tangent for right now. So again, what I have in that box, be very careful that you notice a difference from a cotangent to a tangent. Pause and continue writing. All right, so let's focus on the parent function for the cotangent. Remember the cotangent was a reciprocal of the tangent. So to find the cotangent, you're going to take the opposite of the tangent. You're going to take cosine over sine. So let's talk about that unit circle again. On your unit circle, I have some ordered pairs that I want to focus on. For the angle 0 degrees or 0 radians, that point is 0, 1. If I take the cosine over the sine, so I'm taking 1 over 0, I get undefined. So that's why I have an asymptote at 0 degrees, 0 radians. Now let's come up to this point of pi over 2. I have an order pair over 0 up 1. This is my cosine, that's my sine. If I divide those, 0 divided by 1, I get 0. So my point would be over pi over 2 up 0. Now let's come to this point of pi. The ordered pair is negative 1, 0. Cosine divided by sine. Negative 1 divided by 0, undefined. I'm going to have another asymptote. So I have asymptotes at 0 degrees or 0 radians and at pi radians. These are where your asymptotes occur. So where on the unit circle is the cotangent of x undefined? It's at 0 and pi. Are there more if you continue around? Yes. 2 pi, 3 pi, 4 pi, etc. Where the cotangent being undefined is where your asymptotes will be. So your first two asymptotes are at 0 and pi. If you have any movement, then you're going to go left and right. You set them equal to 0 and pi. The period is the length between two asymptotes. So since this is the parent function, this is your b value, and your b value is 1, your period, pi over b of 1 is just pi. So the period for the parent function is pi. Now let's go ahead and graph 1 revolution. So I'm going to start at 0 radians and stop at pi radians. And then I'm going to create those asymptotes, because we already learned that that's where they are undefined. Now I'm going to go halfway of pi over 2. And then halfway again, pi over 4 and 3 pi over 4. So I've split into 4 equal parts. When I was up here on my unit circle, I noticed that with pi over 2, if I figured out the cotangent, I got a value of 0. So that's my point right here. Now, at pi over 4 and 3 pi over 4, I have 1 and negative 1. My points will be, if I calculate them out, at pi over 4 it's going to be at 1, and at 3 pi over 4 it's going to be at negative 1. So here is what 1 revolution looks like with the cotangent. Again, here is your period of 1 pi You have asymptotes every pi away.